Hi everyone, I have the hiccups, or I have hiccups, not sure how to say that, but I usually don't, which is really funny that I do now. But this is a handout from class about capacitors and inductors. It's a summary page with most of the stuff that you already know from physics that I expect you to remember. And what it is that is the most important thing, the most important things I'm gonna highlight. I equals C dV dt. It's the relationship between current and voltage in the capacitor. And V equals L di dt. I always remember an inductor like a resistor, except better. It's a resistor in steroids. So V equals L di dt is like V equals Ri. And in the end, an inductor is like a resistor, but just really a long wire. And the current through the inductor, we're still following the passive convention, and so it's the current going this way, voltage drop this way. Same thing with a capacitor. You're going to see two kinds of symbols for capacitors in 285. This and this. This is a polarized capacitor. For 285, you don't need to worry about it. The same thing. It's plus on the side, minus, and the current is going that way. The two other things that you may need to use in 285 are that capacitors in parallel behave like resistors in series. You add up. So two capacitors in parallel, you add the capacitance. And when they're in series, they behave like two resistors in parallel. Inductors behave just like resistors. The sum of the inductors in series is the equivalent inductance. And when they're in parallel, 1 over the equivalent is equal to the sum of 1 over each one of them. For next class, and I'm going to upload a video very shortly, we're going to use this fact here that the voltage across the capacitor right after a switch opens or closes is the same as beforehand. So the capacitor holds voltage while the inductor holds current. Now I'm gonna go do the other side of this handout in the next video. We're gonna start doing circuits.